Hi, welcome back to Dr. Zahir Math. In today's lesson, MA101 section 6.8, we learn how to evaluate limits that become indeterminate forms. What do you mean by indeterminate forms? 0 by 0, infinity by infinity, 0 dot infinity, and infinity minus infinity. So indeterminate means the limit cannot found directly. So we need some extra steps. Keep in your mind. For 0 by 0 and for infinity by infinity, we apply L'Hopital's rule, right? This L'Hopital's rule is actually a French mathematician name. Might be your teacher told in the class or not, I'm not sure. So it's actually a French mathematician name. So we can pronounce L'Hopital in a simple way. But most of the English writing people, they write it as L'Hospital rule. So both are seems to be correct, but that is not so important, okay? Don't worry about the spelling. Focus on understanding how to use the rule to solve limits of type 0 by 0 or infinity by infinity. So I'm going to pronounce Hopital rule, right? L'Hopital rule in a simple and English friendly way for students, right? But if you see the French pronunciation, L'Hopital. L'Hopital is the correct pronunciation in French, right? But for English, L'Hopital, right? Okay. So you can say something like this is called L'Hopital rule. Pronounce it like L'Hopital. Don't worry about the French spelling. Just focus on the rule. Again, I'm telling, okay? Right. So 6.8 we are going, and before going to this rule, I will tell you what is the rule and what are the formulas you have to remember. So the list of formulas I'll give you. What is the standard L'Hopital rule? If limit x tends to a, f of x over g of x is of the type 0 by 0 after you putting the limits, or infinity by infinity. If you get this format, then the L'Hopital's rule says that limit x tends to a, f of x divided by g of x is equal to limit x tends to a, take the derivative of f of x, derivative of f of x divided by take the derivative of g of x. No quotient rule. Do the derivative numerator separately. Do the derivative for the denominator separately. Clear, everybody? Right. I put derivative as d. You can use small d. You can use capital D, whatever it is. Do the derivative for the numerator and do the derivative for the denominator. So, until you get the limits become solvable, you can apply repeatedly this L'Hopital's rule, right? Okay. So, keep in your mind, numerator differentiation separate, denominator differentiation separate. Okay. Yes. Now, some more rules I'll give you, which you already studied. E power minus infinity is what? 0. E power infinity is what? Infinity. 1 by 0 is what? Infinity. And 1 by infinity is what? 0. And differentiation of ln x, which we studied in many places, 1 over x. Differential of 1 over x is negative 1 over x square, right? And then one more thing which you studied in the limits in the beginning of module 1. Limit x tends to 0, sine x over x is equal to what? 1, right? And also at the same time, limit x tends to 0, tan x over by x is also equal to 1. And then one more very, very important rule. Limit x tends to 0 plus ln x is equal to negative infinity. This is very, very important rule. Keep in your mind. Limit x tends to 0 plus ln x is equal to negative infinity. Teacher, I didn't understand this rule. This I studied in the first module. This I studied in the first module. This derivative is all I studied. How can you say that limit x tends to 0 plus ln x is negative infinity? A small example tell you. Take your calculator. Just I'll write the x and ln x value. Just type ln x in the calculator, or you put x is equal to 0.1 in the place of x for ln. You will get minus 2.302. and put 0.01, you will get minus 4.605. Wait, my calculator is very slow. So you are putting ln x, ln alpha x, close the bracket, calculate x equals 0.1, I'm getting minus 2 point approximately. Calculate x equals 0.01, I'm getting minus 4.065. And 0.001 you put minus 6.907. Look at here, it keeps on going down. And put 0.0001 and minus 9.210. It means what? As x approaches 0 plus, ln x, right, becomes more and more and more what? Negative. Clear, everybody? Right. So minus infinity is not a finite number. You cannot put x is equal to 0. So you approach 0 from the right and ln x keeps decreasing without bound. So that is why we are getting this rule, limit x tends to 0 plus ln x is negative infinity. And the next rule which you are going to study is limit x tends to infinity e power x. You put x e power infinity, it goes as what? E power infinity is infinity, right? And limit x tends to minus infinity e power x, which is e power minus infinity, which is equal to what? 0, right? And one more rule also you have to remember, limit x tends to infinity x power n. When I put x is equal to infinity, infinity power n, which is equal to infinity. So keep in your mind. So let's start now the first question. Limit x tends to 2, x square minus 4 divided by x minus 2. Put x is equal to 2, 2 square minus 4 divided by 2 minus 2. So you will get 4 minus 4 divided by 2 minus 2, which is what? 0 by 0. So we are going to do 0 by 0 form. So if you get 0 by 0, you can apply L'Hopital's rule, right? You can say Hopital, no problem, right? L'Hopital, sorry, not Hopital, L'Hopital. L'Hopital rule, you can say like that. This is silent, okay? L'Hopital rule. Yes, so 0 by 0. So now you have to apply what? The rule. The rule says that limit x tends to 2, differentiate x square minus 4 and differentiate x minus 2. How simple is it, right? No need of the quotient rule, right? Yes. What is the differentiation of x square? 2x. What is the differentiation of 4? 0. What is the differentiation of x? It is 1. What is the differentiation of 2? Is, sorry, I forgot to put the limit. So let me write here, limit x tends to 2, differentiation of x square minus 4 is what? Which is 2x minus 0, and differentiation of the denominator is what? 1 minus 0. So this equals limit x tends to 2, 2x divided by what? 1. Now we are going to put x is equal to 2. So 2 times 2 divided by 1, which is equal to what? 4. So we got the answer. Very easy. Very easy or not? Yes. L'Hopital rule is very, very, very easy. Keep in your mind. Let's go to the next question. Yes. Now what we are going to do? We are going to put x is equal to 0. Sine 2 times 0 divided by 0. Sine 0 is 0 divided by 0. So we are getting 0 by 0 indeterminate forms. Right. So what the rule says? Limit x tends to 0. Differentiate sine 2x divided by differentiate x. So this equals limit x tends to 0, right? What is the differentiation of sine x? Differential of sine x is cosine x. What is the differential of sine 2x? Which is cosine 2x, and derivative of 2x is what? 2. So this is cosine 2x. 2x is an angle, keep in your mind. 2x times 2. Don't multiply this 2 inside by 4x. No. Right? So over differential of x is what? 1. So this equals, now try to put x is equal to 0. So I will get cos 2 into angle 0, that is multiply by 0. So 2 multiply by 0, multiply by 2 divided by 1. So we are getting cos 0 and times 2 divided by 1. So cos 0 is 1 and multiply 2 by 1 is what? 2. Clear? Let's go to the next question, right? Put x tends to 0, I will get e power 0 minus 1 divided by 0. E power 0 is 1, 1 minus 1 divided by 0, I will get what? 0 by 0. If it is case, then you can use L'Hopital rule. What is L'Hopital rule? Differentiate the numerator separate and differentiate the denominator separate. So this equals differential of e power x is what? E power x. Differential of 1 is what? 0. Differential of x is what? 3x square, right? Now you put limit x tends to 0. So when I put limit x tends to 0, I will get e power 0 minus 0 divided by 3 into 0 square. So e power 0 is what? 1. 1 minus 0 divided by 0. So 1 by 0, which is equal to what? Infinity. Clear, everybody? So easy. Let's go to this question. Come on, put t equal to 0. 0 e power 0 divided by 1 minus e power 0. So d by 1 minus e power 0 is 1. So which is 0 by 0, which is indeterminate form. So now you use L'Hopital rule. So when you use L'Hopital rule, you should be very careful. There is a product in the numerator. So differential of t e power t divided by differential of 1 minus e power t. Right. Now look here. What is the differential of t e power t? This is of the model uv, right? So what is uv rule? U times v dash plus v times u dash. So this equals, what is your u? T. Differential of e power t is e power t. What is v? E power t. Differential of t is what? 1. So let's apply here. So limit t tends to 0, t times e power t plus e power t. I just apply this one here, okay? Right. Over, and differential of 1 is what? 0. Differential of e power t is what? E power t. So this equals limit t tends to 0. Let me simplify. T e power t plus e power t divided by what? Minus e power t. Now put t equal to 0. When I put t equal to 0, 0 e power 0 plus e power 0 divided by minus e power 0. Right? So this equals 0 e power 0 is 1. E power 0 is 1 divided by minus e power 0 is 1. So this equals 1 divided by 1, which is minus 1. You can also put in the calculator, no problem, because you can type e power 0 in the calculator. Let's go for the next question. And limit x tends to 3, x divided by e power x. Put x is equal to 0. Yes, and then e power 0. E power 0 is what? E power 0. E power 0 is 1, right? X is equal to 3, right? I put it as what? X is equal to infinity. Sorry, this is not 3. This is infinity, right? Wait, sorry. Right, x is equal to infinity, right? Divided by e power infinity. So this equals infinity, right? And then divided by what? E power infinity is also infinity. So it is infinity by infinity, which is indeterminate form. So what the rule says, limit x tends to infinity. X, what is x? Derivative of x divided by derivative of e power x. Derivative of x is what? 1. And derivative of e power x is what? E power x. Now you put x is equal to infinity. So e power infinity. So e power minus infinity, right? When I bring it to the numerator top, flip. So e power minus infinity is what? 0, right? Yes. Let's go to the next question. Next question is a little bit important question. Keep in your mind. Limit x tends to 0 plus ln x over cosecant x. L'Hopital rule, right? Yes. Just now I gave you the formula. Remember, limit x tends to 0 plus ln x is equal to negative infinity. Remember, this is a rule I gave in the front page. You just go ahead, go back and look again. So when I put 0 plus, I will get minus infinity. When I put this cosecant x, what is cosecant x? Cosecant x is nothing but what? 1 by sin x, right? So you will get what? 1 by sin x. Suppose you write this sin x, for example. So if you write this sin x, what will happen? So it is ln x, right? And then 1 by cosecant x is what? 1 by cosecant x is equal to sin x, right? So suppose I write ln x sin x. You put sin x is equal to 0 plus. It becomes what? 0, right? So automatically it becomes this one, right? 0. But we want infinity by infinity, right? So what can I do this one? How to write this one? Can you give me any idea? Okay, did you think about any idea? Okay, I will explain it again, no problem. So I write ln x and I write 1 by sin x, right? Sorry, 1 by cosecant x. 1 by cosecant x, because this ln x. When limit x goes to 0 plus, this becomes what? Minus infinity, right? And limit x goes to 0, you will get what? 1 by cosecant 0. 1 by cosecant 0. Sine 0 is 0. Cosecant 0 is 0. So 1 by 0, it's again going to become what? Or you can say cosecant 0. You'll get what? 1 by sine 0, right? Which is again become what? Infinity. So this is going to become what? Minus infinity divided by infinity, right? Got it or not? No. Again, I will explain. Listen carefully. So this is by the rule, it becomes minus infinity, right? So this is 1 by, when you put x is equal to 0, you will get cosecant 0, right? So this is minus infinity. Cosecant 0 is what? 0. Because sine 0 is what? 0. So minus infinity. 1 by infinity is 1 by 0 is what? Infinity, right? Yes or no? So infinity. Not clear? Okay. So I'm just making you to confuse. Nothing to worry. So I will do it again. Okay. Now I'll give you a simple idea. Right. This is ln x, right? 1 by cosecant x is what? Sin x. Now you put x goes to 0 plus. So this becomes what? Minus infinity. When I put sine 0, this is 0. So finally you get what? Minus infinity 0. This is also what? Indeterminate forms. Keep in your mind, okay? Indeterminate forms, right? Either infinity by infinity or minus infinity 0 is also indeterminate form. So L'Hopital rule is allowed, right? Yes. Now what we need to do? We need to write in the same question in a quotient model. So I will write it again. Limit x tends to 0 plus, right? So you're going to write it as what? Ln x divided by cosecant x. So now I'm going to apply the rule. So when I apply the rule, limit x tends to 0 plus differential of ln x and differential of cosecant x. So this equals, what is the differential of ln x? 1 by x, right? Yes. And what is the differential of cosecant x? Minus cosecant x cot x. Clear everybody? Right. So one small adjustment I'm going to do it. Listen carefully. Cosecant x, we can write it as what? 1 by sin x. You know very well. Cot x, I can write it as what? Cos x divided by what? Sin x. Why? Because tan x is what? Sin x divided by cosine x. Tan cot is what? Reverse, right? So the same idea I'm going to follow. So 1 by x in the top divided by minus, this is 1 by sin x and this is cosine x divided by sin x. Clear all of you? Right. So now what happens? This is equal to, let me see pages there. Yes, is there. So 1 by x I'm not touching. It's keep it as it is. This you're going to flip it. Minus I'll keep it. So this is sin x divided by 1. This you flip it. You will get what? Sin x divided by what? Cosine x. Right? Now, what is the limit? I forgot to put the limit. This equals limit x tends to 0 plus. Take any one. Now, you know very well that is this sin x divided by x. When the limit goes, x goes to 0, I gave as a rule. Remember? Limit x tends to 0. Sin x divided by x is equal to what? 1. So, this part is equal to 1. So, now this is equal to, right? Limit x tends to 0 plus minus sin x divided by cosine x is what? Which is tan x, right? Now you put x is equal to 0. I will get minus tan 0. Tan 0 is what? 0. So you're going to get what? 0. Clear everybody? Right. Let's go to the next question. Limit x tends to infinity, e power 3x divided by x square. Put x equals infinity, e power infinity. 3 infinity is infinity. Divided by infinity. E power infinity is infinity and this also infinity. So now what we are going to do? Limit x tends to infinity. Differentiate e power 3x by differentiate x square. So this equals what? E power 3x times 3. Sorry, e power 3x times 3 in the down. Divided by 2x. Now you put x tends to infinity. What happens? When I put x tends to infinity, 3 times e power 3 into infinity divided by 2 into infinity. Again e power infinity is infinity by infinity. Again it's indeterminate form. So until you get the answer, you are going to do, that means answer in the sense not an indeterminate form. You are going to do it again and again. So this one again you are going to differentiate. So this equals 3 times differential of e power 3x divided by 2 times differential of x. Teacher, I can put 3 inside, I can put 2 inside. Yes, you can put it, no problem. So this equals, when I differentiate this one, e power 3x times 3 divided by, when I differentiate x, I will get what? 1. So 2 into 1. So I'm getting the answer. 3 is 9 e power 3x divided by 2. Limit x goes to what? Z infinity. So when I put infinity now, 9 by 2 e power infinity is what? Infinity. So we are getting infinity. Clear everybody? Right. Infinity is allowed, but infinity by infinity is not allowed. Let's go to the next question. What we are going to do? Limit x tends to 0 plus. So I'll tell you, I was muted for calculator. Okay, phone came. Okay, right. 0, listen everybody. 0 dot infinity. If you get 0 dot infinity, right? That means this situation. 0 dot infinity or 0 multiply infinity or 0 multiply minus infinity. If you get a situation like this, convert into division format. Again, I'm telling, convert into division format. So once you get a division format and then apply the rule. So now we are going to do this problem. Limit x tends to 0 plus x ln x. So what happens now? So x you put 0 and ln 0 when limit x tends to 0 plus is minus infinity. So you are getting this model 0 times infinity. So what we are going to do, you write in the fraction model. You write in the fraction. Okay, that is called division model. So what I'm going to do, I keep this ln x. But this x I'm bringing down as 1 by x. Flip it, it will go up, right? So keep it like this. Then start applying the rule. What is the rule? Numerator differentiation separate and denominator differentiation separate. What is the differential of ln x? 1 by x. What is the differential of 1 by x? Minus 1 by x square. Clear everybody? Now this equals 1 by x. Flip it. Minus I take it out. X square divided by 1. So you're going to get the answer what? Minus x. Clear? Minus x. Right. Now what we are going to do? We are going to put x tends to 0 plus. So we are going to get what? Minus 0. Minus 0 normally we don't write. We are writing plus 0. Right? I think too many problems are there. Let me go to the next question. Limit x tends to infinity, x e power minus x. Put x is equal to infinity and e power minus infinity. You will get infinity times 0. If you get like this, write this in the fraction model. Write in the fraction division model. How to write division model? Very simple. Limit x tends to infinity, x. This e power x, bring it to down. So you will get what? E power plus x. Now you apply the rule. Limit x tends to infinity. Differential of x and differential of e power x. What is differential of x? 1. What is differential of e power x? E power x. Put x tends to infinity, 1 by e power infinity. So 1 by infinity is going to become what? 0. Right, let's go to the next one. Infinity minus infinity model. If you get infinity minus infinity, keep in your mind, make it single fraction. Make it what? Single fraction. Keep in your mind, make it single fraction and then apply the rule. These are all some shortcuts you need to remember. Right. So let me start now. If you put 0, 1 by 0. If you put sine 0, sine 0. So 1 by 0 minus 1 by 0. Infinity minus infinity. Can you see that? Yes. If it is like this, make it as single fraction. Make it as what? Single fraction. Okay. How to make it single fraction, teacher? Just take LCM. That's it. Limit x tends to 0 plus. Okay. So take this one, magas. That is called single fraction. That's it. So x sin x in the down. And then here sin x minus x. Very simple. This is called a single fraction. Single fraction means like this, only 1. But here it was 2, right? Yes. Now what I need to do? I need to apply the rule. What is the rule? Limit x tends to 0 plus, right? Differential of sin x minus x divided by differential of x sin x. Right. Here there is a product rule. Can you see that? Here there is a product rule. Keep in your mind. Okay. Yes. So x sin x, this is u and this is v. Right. U and V, right? Yes, so what is that? Keep U, differentiate sin x, cosine x. Keep sin x, differentiate x is what? 1. Right. Now let's start the differentiation. So limit x tends to 0 plus differential of sin x is cosine x minus differential of x is 1. Right? Divided by this one, I'll bring it here. X cosine x plus sin x. Now you apply 0. When I apply 0, I'll get cosine 0 minus 1 divided by 0 cosine 0 plus sine 0. So this equals cosine 0 is 1, 1 minus 1, and this is 0. I think x cosine x. I think I missed something. X sine x. 1 minute. Differential of x sine x. X into cosine x plus sine x. Okay, right. 1 minute. Yes, I'm right only. Cosine 0 is 1 minus 1 divided by this is 0. This is 0. So this is 0 by 0. Again, you're getting indeterminate form. So what I need to do, I have to differentiate this one again, right? So let me erase this one, right? So again, I have to differentiate this one. So limit x tends to 0 plus, am I right? Yes. Now this one I have to differentiate again. So differential of cosine x minus 1 divide by differential of x cosine x plus sin x. X cosine x plus sin x. Okay. This equals, the numerator is okay, denominator you have to apply. So there is a product rule, differential of x cosine x. This is u, this is v. So x into cosine x is what? Minus sin x. Plus cosine x into x is what? 1. So what happens? Numerator cosine x is minus sin x minus 1. Okay, limit x tends to 0 plus divided by differential of this one is minus x sin x plus cosine x, which is here. Okay, right. And then plus sin x derivative is what? Cosine x. This sin x derivative is what? Cosine x. Now let me try to put the limits. I'm getting the answer or not. Let's check. Minus sine 0 is 0. Minus 1. What I did? Oh, minus 1 derivative is 0. So this is not minus 1. Sorry. Minus 1. Cosine x derivative is minus sin x. Minus 1 derivative is what? 0. Divided by, right? When I put x equals 0, sine 0 is also 0. Cosine 0 is 1. Cosine 0 is 1. So I'm getting minus 0 divided by 0 plus 2, which is equal to 0 by 2, which is equal to 0. Wow, to get 0, we worked a lot. Yes. So this finishes your last question. I hope the answers are correct. Okay, it's almost night, 11:30 something. So, no, 11:10 something, right? Yes. So this finishes your exercise 2 point. Let me see the exercise from your classwork homework sheet. It is 6.8, sorry. So this finishes your exercise 6.8. Clear, everybody? Right. So this is a lengthy exercise, but the same idea problem is keep repeating. That's what I wanted to say that. Okay. Right. So Alhamdulillah, we have completed all important examples from section 6.8. Now you should be comfortable in identifying indeterminate forms and applying Hopital's rule correctly, right? So practice these please 4 to 5 times and you'll be very confident in the exam. See you in the next video, inshallah. Stay focused and keep learning. East or West, Dr. Zahid Math YouTube channel is the best. Bye-bye.